High-ranking military officials now admit 3I Atlas may not be what it seems, but something far more terrifying.
My name is Jeffrey Nusatelli. I'm a former military police officer with 16 years of active duty service in the U.S. Air Force. I'm here today because the American people have both the right and the responsibility to know the truth about unidentified aerial phenomenon. That truth remains hidden, classified, and silenced by fear, retaliation, stigma, and confusion. Today, we are here to help break that silence.
Astronomers used to call it a flyby. Now, some use the word arrival. 3I Atlas isn't just passing through, it's cutting across the solar system on a path lined with major worlds. And here's the shocker. NASA's instruments are showing it might be moving faster than our models predicted. That means the countdown to its Mars, Sun, and Jupiter encounters may come sooner than expected. If the Navy's interest is any sign, scientists believe this object's approach deserves our full attention. So why does this matter now, and what might we see when it gets closer? Before we move on, please take a moment to subscribe to the channel and like the video. At first, astronomers placed 3I Atlas into the familiar category of comets, the icy fragments that pass through the solar system from time to time. It had a glow, it showed a tail, and it resembled the countless small wanderers already cataloged. But as instruments began to collect readings on it, the numbers simply stopped lining up. Instead of fitting the pattern of a normal comet's chemistry, this one flipped the expectations upside down, forcing experts to ask whether it could be the first of its kind, something arriving from deep interstellar space with a recipe that didn't belong here. The object was first picked up by the Asteroid Terrestrial Impact Last Alert System, or ATLAS, a survey net of telescopes based in Hawaii designed to detect threats approaching Earth. At an extraordinary distance beyond Jupiter's orbit, the system flagged its movement and brightness as suspicious. The speed and angle seemed out of touch with the circular paths we know from objects bound to the Sun. The identification as an interstellar traveler came before it had even crossed into the inner solar system, which is unusual since most comets are not recognized until they are much closer and brighter. But what truly pushed 3I Atlas into the realm of mystery was not its trajectory, or at least not yet. It was its makeup. In standard comets, frozen water dominates, and carbon dioxide appears only in smaller amounts. Here, the ratio looked all but reversed. Instruments saw high levels of carbon dioxide streaming away, with water scarce by comparison. That alone was enough to mark it as peculiar, but the oddities did not end there. Its coma, the glowing cloud around the object, scattered light at angles that physicists struggled to reproduce with known materials. The grains didn't behave like ice, nor like dust, and no easy laboratory experiment could make the scattering pattern appear the same. Peeling further into the spectrum of elements, scientists began to note an even stranger signature: the presence of nickel but little to no iron. Under ordinary cosmic chemistry, the two appear together almost as a rule. Stars fuse them, meteorites carry them, and comets trap them. To find substantial nickel without iron was like finding a pair of shoes with no soles. The contrast pulled at common sense, as if universal laws had been bent or rewritten in whatever ancient nursery produced this traveler. If someone needed a grounded comparison, imagine standing beside a car on the street and realizing it has no tires, no headlights, and yet somehow still moves at highway speed. That is the type of mismatch experts confront when pointing spectrographs at 3I Atlas. Even seasoned researchers accustomed to surprises turned cautious, knowing that every new measurement seemed to cross off another assumption. We've seen oddities before in objects from outside. Oumuamua, the first interstellar visitor, showed a long and thin profile with no visible coma, spiraling away, propelled by something nobody could quite pin down. After that came Borisov, which appeared more like a textbook comet, yet moved too swiftly to be from our own neighborhood. Both cases broke parts of the rulebook, but each still allowed fragments of familiar behavior. 3I Atlas set itself apart by breaking several rules at once. Its possible birthplace appears older, its chemistry tougher to explain, its presence more disruptive than either of the first two. This is why scientists talk with such care now. Collecting data is essential, but this time it feels less like ticking off measurements from another icy rock and more like preparing for a close encounter people alive today will never see repeated. With every observation, the stakes rise. A comet's bright face normally tells us the same old story of water ice and dust warmed by sunlight. Here, the story already runs in reverse, and many are waiting to find out whether even deeper oddities will show themselves when the sun heats it further. You could think of it as a window into an older cosmic environment, one shaped before our solar system even formed. In that sense, it isn't only a comet, at least not in the way the word has defined every other visitor before it. It looks less like a random iceberg drifting through the dark and more like a messenger carrying material from an environment humanity has never directly touched. And if the chemistry tells us this story, then its voyage through space promises an even stranger chapter, because while the elements say it is alien, its next steps across the planetary orbits raise questions about whether its journey looks natural at all. Why does 3I Atlas seem to be sewing its way through the solar system instead of ripping straight past like a reckless stone from deep space? That question has started to haunt astronomers mapping its unusual path. For a body that is supposed to arrive from interstellar space, you might expect a line like a dart, plunging in, curving around the sun once, and then departing forever. But that is not what the orbital charts show. Instead, its course flattens neatly into the solar system's plane, the same thin sheet where all the major planets orbit, and from there it threads uncomfortably close to Mars, Earth, Venus, and even Jupiter. The ecliptic plane is a crowded billiard table of worlds and smaller objects, so the odds of something plunging in from a random direction and sliding along that very sheet seem low. In most cases, incoming comets cut across at odd angles, slicing through the solar system like a needle-piercing cloth. Their tilted angles make sense. Interstellar arrivals should not care about the orderliness of planets bound to the sun. 3I Atlas, however, behaves differently. Its line does not cut across like a blade, but flattens out, aligning like a visitor who knows exactly where to walk in a busy hallway. When lines are drawn against planetary tracks, the picture becomes even stranger. Its route does not just align with the general plane. It appears to weave close to key orbits as though following intermediate markers. Near Mars in one leg, by Earth not long after, near Venus, and then drawn outward again toward Jupiter. Each point looks like a stop on a path rather than a mere coincidence of geometry. It raises the uneasy thought. How random can this really be? Instead of a single brush with the sun, the movement feels more like a sequence of short visits, as if an interstellar tourist were taking a slow-motion tour. Visualizations of its passage drive home the unease. Traced against the pale blue curves of planetary orbits, the red line of 3I Atlas threads through at multiple intersections. Anyone who has seen models of typical comets will notice the difference. Random comets plunge steeply, skim, and vanish back into the dark. Here the pattern almost mirrors a deliberate traversal from world to world. Such tracking makes language matter. Some astronomers no longer reach for the neutral word flyby when explaining it. Instead, the word arrival has begun to appear in public statements. It is a subtle shift, but one that carries more weight than casual listeners might notice. A flyby passes by without contact. An arrival implies presence, perhaps even intent. Even outside the scientific community, the choice of words signals changing focus. The fact that agencies beyond astronomy, such as the US Navy, have had their names mentioned in relation to the object shows that its path is treated with exceptional seriousness. For groups trained to think in terms of tracking, positioning, and threat analysis, an object whose trajectory can be drawn like a route map invites suspicion. It's not simply about what it is made of, but where it is going and why it passes by the worlds it does. Alertness grows in this space when things stop looking chaotic and start to resemble alignment. Does this mean it is controlled? No evidence exists to leap to that conclusion. Yet the fact that such a question even surfaces shows how unusual the line looks compared with everything else currently under study. Scientists know that upcoming encounters may be decisive. When it meets Mars or glows brighter near the Sun, they may catch clearer signs of whether its movement is shaped by coincidence or if deeper dynamics steer its way. In other words, the next months will test if the arrival label is metaphorical or descriptive. What is already clear is that its journey does not appear careless. Each intersection with planetary space reads like part of a pattern, and perception matters. Humanity's reaction to these rare interstellar visitors shifts depending on what story their behavior tells. With 3I Atlas, the story is no longer of a stranger brushing by, but of something walking a route with recognizable stations. That changes the way researchers prepare, and it shapes what the public imagines may happen next. And while the pattern alone is enough to raise questions, the real drama is about to unfold in real time. Because soon, rather than just lines drawn on orbital graphs, we will witness the step-by-step encounters as it sweeps by Mars, dives near the Sun, and moves outward toward Jupiter. Imagine being able to watch, almost in real time, as an interstellar relic moves across the stages of our solar system. First, it brushes the orbit of Mars, then it plunges dangerously close to the Sun, and after disappearing for weeks, it reappears to make its way outward before swinging near the giant planet Jupiter. Each step carries its own opportunity to learn, almost like chapters in a story that no one on Earth has ever read before. This is not just another comet pass. It is a narrow period of time where instruments must be ready, because once it is gone, it will be gone for good. The dates are already circled. In October of 2025, the object will sweep near Mars in what could be the first close glimpse of its hidden solid core. Just weeks later, on October 29th, it will reach its closest point to the Sun, the moment astronomers anticipate most, because solar radiation may reveal what ordinary observations cannot. By December, it should emerge again, this time stripped, altered, or possibly broken apart into visible fragments. And then the march forward continues, this time toward Jupiter, where in March of 2026, it could brush past the domain of the gas giant, giving one final chance for a major space mission to get a close look at it before it sails away into darkness forever. The tension behind these dates comes from how short and unforgiving the window actually is. Mars, in late October 2025, offers only a brief chance, less than a week, for cameras to catch the object as it moves away. Miss the timing and the data is lost. Perihelion around the Sun is the single best chance to strip away the veil of gas and dust. But here too, timing is strict. The coma may grow, the nucleus may fragment, or it may become too bright for certain instruments and too faint for others as it fades back out. By the end of March 2026, the final chance passes, and no instrument will be able to bring it back. 3I Atlas might be more than a comet racing by. It could be the oldest story ever carried through space. The Otau-Tahi Oxford model suggests it may be around 7 billion years old, older than our solar system itself. That age explains why its chemistry feels so alien, storing material from a time before Earth even formed. If it moves quicker than predicted, the countdown shortens, forcing discoveries sooner than scientists thought possible. So the question becomes, is this only an ancient relic passing near us, or the first moment human observers witness our solar system hosting a wider galactic conversation?